Hey everybody, today's video is on quadratic patterns of change. Our objective for today is to write equations of quadratic functions given the vertex and one other point. So if I were to give you a point, the vertex right here, hk, which would be given in some form, and then as some numbers, and then also another point, let's say a and b, then you could, based on some stretches, some shrinks, whatever, you could write an equation for that quadratic. Oh, it's going to be good. So let's get it started. All right, hey guys, so what we need to first do is establish what's called a pattern of change. So I'm going to look at the function y equals x squared. So let's say I have inputs of 1 and 2 and -1, -2. Okay, so as well as 0. So if I plug a 0 into y equals x squared, I get 0. If I plug a 1 in, I get 1. If I plug a 2 in, I get 4. So there's this special pattern of change with a quadratic, specifically this parent function. It's called a parent function because there's no transformations being performed on it. And the nice part is we already know is that the axis of symmetry right here will be at 0. Therefore, the graph will look symmetrical around that y-axis. Okay. So also, let's take a look at the function y equals -x squared. So -x squared is going to be the same image, just flipped vertically. So all the points are the same, except the outputs are the opposite sign. Okay, so as we look at this thing called pattern of change, what I want to do is I want to look at the change in x from the vertex. And this applies to any quadratic function, as well as the change in y. And then we're going to use this pattern also from the vertex. We're going to use this pattern to determine and figure out our main objective, which is to come up with an equation for a quadratic given the vertex and another point. Okay, so let's look at the change in x. So if the change in x is 1 from here to here, the change in y will either be 1 or -1, right, in a general parent function quadratic. If it's -1, it'll be positive or -1. So, like I said, if the change in x is plus or minus 1, then the change in y should be plus or minus 1. Okay, what if y, or change in x is 2? Well, if the change in x is 2, the change in y should be positive 4 or -4. Same thing over here. Change in x is -2. Change in y will be 4 or -4. Okay, so plus or minus 2 will give us plus or minus change of 4. Now we could extrapolate this out and go with plus or minus 3. You're probably predicting plus or minus 9. And then, of course, the further you go out, you're just going to follow this pattern. If it were plus or minus n units in the right or left direction, you get plus or minus n squared. So it is what it is, right? That's the function. The function is x squared. So as you change 4 units in the horizontal direction, the vertical change will be 16, which is just that value squared. Okay, so we've established that. Let's look at how we can use that on the next slide on an example. Okay, so here I've sketched a quadratic function. That function is opening down, which tells us that a will be less than 0. Its vertex is 2, 3, and another point on it is 0, 0. So I've got a little bit of information. If a is less than 0, then I know that this value will be negative. And if the vertex is 2, 3, then I know this would be x minus 2 plus 3. So all I've got to do is find the value for a. So let's look at first our foundational pattern of change. So change in x. Notice that my change in x here is -2. So I said that if there is a change in x of -2, that our change in y would be plus or minus 4. Should be plus or minus 4. Okay. Let's look at the actual change in x here. Well, the actual change isn't going to be indifferent. It's -2. But our change in y is the problem. It's not -4. You can see my change in y here is -3. So it's negative 3. Okay, so what have I done to change the pattern of change? Well, what I've done is I've taken negative 4, which is what I should have seen in a quadratic, so I'm going to scratch the positive 4. I've taken negative 4 and I've multiplied it by a, and that's given me a new pattern of change, which is negative 3. When I divide by negative 4, I get a equals 3/4. And there you have it. Now, don't be fooled. I said a equals 3/4. That's because I've already accounted for the fact that it's negative. Okay, so that's the equation of our quadratic function. So its pattern of change is now 3/4 of what it would have been in that parent function. Okay, we've got a max value at the vertex, and we've got all the attributes that we need in order to then write this equation in any form. We could write it in standard form, factored form, all that good stuff. We just have to expand if asked. All right, let's do one more example. All right, our second example for today, we're going to put this into write the equation in vertex form, as we see here with a bunch of blanks. Let's get to it. So we got a vertex. Vertex of -2, -5. I'm going to input that in here. That makes this as a +2 and minus a negative, and -5. Okay, so all that we need to know is a greater than or equal to 0, or is a greater than or less than 0, and what is the value for a. So since this quadratic opens upward, I know that a will be greater than 0, so that'll be a positive value. Now I'm going to look at the patterns of change. Looking at the parent function pattern of change, it looks like I do a change in x from -2 to 8, which is a change of 10, which tells me that my pattern of change for y should be 100. All right, I should square 10, get 100. Actual pattern of change, x, no difference. It'll be 10, but my change in y here looks to be from -5 to 7 is 12 units. Okay, so what I've done, as I showed earlier, is I've taken 100 times a and gotten 12. Well, if I do a quick reduction on that, that's a equals 12 hundredths, or both of those are divisible by 4, so 3/25. So it looks like the equation of my quadratic function is y equals 3/25 quantity x plus 2 squared minus 5. There you got it, guys. I'll do more with quadratics and using different methods to just talk about the attributes of quadratics. But for today, that's it. Hope it went well. Let me know if you want some content. Comment down below, and we'll see you in the next video.